There it goes. Let's plug it back in. Run real flight. Ah, come on. Look. Looks like it's not gonna work today. So, I guess I'll get onto a different video. Hey everyone, I'm Spiderman. Today I was going to show you how to take off, fly a pattern, and land on my RealFlight 6.5 simulator. But as you saw, that's not going to work out today. Or for a long time, because I'm going to have to upgrade to a later version or get a new controller, both of which will take a while. So, I'm going to give you a science course on how airplanes fly through the air. So, there are two main theories. The Newtonian theory. Okay, that does work. The Newtonian theory. And the Bernoulli's theory. So, what I just drew are airfoils, which is the cross-section of a wing. Most wings are not flat. They have these shapes, which I will explain in a moment, as I explain how the wings work. So, the Bernoulli's, I'm going to talk about Bernoulli's first, actually. The Bernoulli's states that these two air molecules will separate over the wing and meet up, moving in the exact same speed after the end of the wing. So that means that this will accelerate over the top of the wing, and this will remain at a constant speed, because this has a lot longer to travel over the curved surface of the top than this does up the flat bottom. So that means lower pressure on top, because Bernoulli also stated that fluids moving faster have lower pressure. And he did several experiments to confirm this. He didn't just state it and say it's law now. So this has a lower pressure on top, and this has a higher pressure on top, which means that there will be a suction force pulling the wing into the air. Now, the Newtonian theory says that air will be deflected by the wing downwards. So that means that the wing is pushing on the air, so that means that the air must be pushing equally and oppositely on the wing. So this is why wings have the shape that they have. Most airfoils do have this curved shape. There are a few light remote control airplanes or chuck gliders that you can have that will have a flat wing, but typically you'll see something like this, or maybe a symmetrical airfoil, which will have curve on both the top and the bottom. I'm not a very good artist, don't judge me. That's the reason why they have the shape that they have. A symmetrical airfoil is actually really interesting because it relies on both Bernoulli's and Newton's theories, because when it's pitched slightly upwards, the air is going to be striking here, which means it's going to have farther to go over the top than the bottom, thus Bernoulli's. But it's also going to be deflecting air downwards, such as Newton's. This type of airfoil is seen on aerobatic airplanes because they're just as happy flying right side up with their wings as flying, here, let me add a tail on that to make it look more airplane, as flying upside down with that type of wing, because, hey, the wing doesn't know the difference, it's symmetrical. So it'll produce lift both upwards and downwards, so it can do cool acrobatic maneuvers such as flying inverted, flying big loops without losing altitude, barrel rolls, flat spins, really cool stuff.